So why would you want to combine human and machine intelligence? I'm going to tackle this today from 3 points of view. One is that human interpretation is needed for less resource languages. Another is that you get better than off-the-shelf accuracy to the level that you can correlate with actual human behavior, something you simply don't get from non-adaptive off-the-shelf models. And three, it's often the only way that you can get critical data in a lot of languages and for a lot of use cases. This is every human communication this year. So in green, by word count, these are the languages that people are speaking. So you'll see that Chinese makes up about 15% of all communications globally. English, Hindi, and Spanish each make up about 5% of day-to-day spoken conversations by word count. Arabic only just slightly less. So 7% of our communications are not spoken. That's the section down in the bottom right here. These are technology-enabled communication. So in blue, phone-enabled, SMS, text messages, and phone calls. In red, internet-enabled communications. To get an idea of what this looks like in terms of what people are currently sharing on Instagram, if you took the adage, and similar, if you took the adage that every online picture is worth 1,000 words, the scale would only be about double social media. So for all the pictures that we're taking of our food and our cats, it actually is still a relatively small amount of data by this metric compared to the amount we're actually typing. To highlight what it means to be low resource, your browser or computer will not show Sundanese script. So it should not look like this or the question marks that you might get elsewhere. It should actually look like what, in this case, I put in as an image, because while this script does exist in Unicode, it doesn't ship by default with any browsers or with any computers. And Sundanese is a widely spoken language. Its speakers outnumber the populations of New York, London, Moscow, and Tokyo combined. So you've certainly heard of all these places, but you might not have heard of Sundanese. In fact, you probably misread or misheard Sundanese as Sudanese when I said it. Sudanese is a variety of Arabic. Sundanese is a language spoken on the island of Java. Barack Obama lived in the middle of the Sundanese-speaking area. He's now your president. This is not necessarily just a corner of the world, which is unrelated to being here in the US right now. But nonetheless, the two scripts from the island of Java, Sundanese and Javanese, don't ship by default with any browsers, which is somewhat ironic given that JavaScript is the name that we've given. Imagine that you're looking at Ford. You're perhaps looking maybe at like online marketing, what's blowing up on Twitter, customer service, you know, any kind of data that you're pulling in. You don't want to get any false signals every time Harrison Ford releases a new movie, or maybe you do if you're a Star Wars fan, but that's unrelated to your analytics. Or the next time that Rob Ford gets himself into trouble in Toronto. So distinguishing the correct Ford, you can think of it as a variant of an identity recognition task. So is it Ford the company versus Ford a person? So using fairly standard features, words, engrams, word shapes, this is the accuracy that you get on this task, in the supervised learning task, with a regular linear model. So this is about 0.45 F value, which is actually reasonable for an NER task. It's a reasonably difficult task. So if you apply deep learning to this task, then that accuracy goes up by about 2%. That's consistent with what we've seen in deep learning applied to natural language processing. So deep learning hasn't given those gains that we've seen in speech and image processing. 2% is still huge. 2% gain in something like NER is worthy of a PhD. Whereas if we go to something like simple in-domain training, so your training data comes from text related to the auto industry in the first place, then that accuracy gets you to about 60% accuracy. If we give the right items, which are ambiguous and representative, or the clients or outliers to analysts for review for just 10 minutes, then that training data can be bootstrapped to automatic analysis of about 95% accuracy. And that all you need for that is a native speaker. So compared to an incredibly smart PhD or an engineer that you need to pay $300,000 a year to and let them sit in a room for 5 years and figure it out for 2% gain in accuracy, getting native speaker feedback for just 10 minutes in the right way can get you orders of magnitude greater accuracy. So a real-world use case here. Edmunds.com is the most visited site in the world for information about car features, and we power the database behind that website. So looking at PDF documents about different cars, Idibon is able to pull out, for example, when someone is talking about air conditioning or climate control or front and rear zones, that we're talking about the same thing. There's different phrases that people use across different makes and models. Help Edmunds normalize that so that they can serve on their website information about what a car should cost across 5,000 different features, regardless of what those features are called on different makes and models. And a great example of integration between human and machine learning. So they require 100% accuracy. Before we worked with them, this was a purely manual task, and it was taking them sometimes 2 to 3 weeks to get information about a car from PDFs onto their website. Now we're getting this down to 1 to 2 days. Every data point is still reviewed by a human, so they're still getting that 100% accuracy, well, the same level of accuracy that they'll get in. But we're able to remove all the redundancy for them. If we look at text messages and whether they're sent from the most developed or less developed parts of the world, 20 years ago, it's kind of at the small end of the graph here. 20 years ago, there were about twice as many text messages sent from the wealthier nations as the whole rest of the world combined. 10 years ago, it was almost equal. Now, it's probably about 4 or 5 to 1. So in the last 10 years, we've seen the amount of communication, so that the data that's being exchanged, primarily come from countries and from people who don't have the same resources that we do.